Good cold Sunday morning to you. We got close to 12 inches. I would say 10 and a half, between 10 and a half and 12. And I snowblowed and shoveled. It's very light, powdery snow. That's one good thing. And, well, I guess we're going to open up the shop. I'm going to turn the heater on. The birds are eating good. Well, the other day, my manual came in for the tube tester from Glendale Manuals. They're on eBay. They were $8.99, but it gave the instructions, the schematic, and of course the tube setup charts. This is a Radio City Model 308. 308. The tube tester is still on the bench as I left it in the first part of this video. And I'm not doing anything with it today because I don't have the parts. The resistor that I showed you, which was disconnected here, it shows a single resistor, 18,000 ohms. So I'm estimating probably a 10 watter. Maybe that's only a 5, I don't really know, but I'd put a 10 watter in there. Or maybe a 5 would do it. I'll have to measure the current and see. It doesn't draw that much, but when there's a tube in the tester, then it will draw more because it's got to go through the wire wound. And judging from this wire wound, I would say this wire wound here is a good 10 watts anyways. Now it just came in the shed, so it's very cold. The electric heater's been going, the little one there. Been busy trying to keep warm and keep the yard clear of snow. It don't take long to get this place up to temperature, but everything is very, very cold. Even with this little electric heater. Tried to just take the chill out so it doesn't get super cold in here. I'm going to redesign this because what's happening is this thing here is slipping on the bar. Even though it's tight, this whole bar is turning in the C-clamps. And I could probably drill them, put a screw through it to keep it from turning, but there's too much flexing here and it sways. The gooseneck idea is alright, but I think I got to redo this. And I'm not sure exactly how I'm going to do it. So that's going to have to be redone, so I'm going to have to address that problem before too long here. I do have a question for you guys out there on this particular tester and testers like this. Kind of like to get a little feedback from you out there as to originality. Now, obviously, anything that's component that's bad has to be replaced. First of all, would you just replace this capacitor, which is a 0.03, by the way. It's for the shorts test, as I said before. No doubt it's leaky. Would you restuff it? Or would you just replace it? It would be awkward to get in there because it's underneath this dog bone, so it's going to be hard to get in there. And trying to get it back in, tucked in there, would be impossible. I may have to bring it out to here. But the question is, do you need to get that fussy? It's not a museum piece, but, nevertheless, you want to have it working. This, according to the schematic, is not a capacitor. It appears to be one. Let me get some light on here. It appears to be a capacitor. Certainly looks like one. But it's in series with one side of the meter, and I'll pull the schematic out. I made a copy of the schematic. I saved it as a JPEG and then I enlarged it, and I'll work from that rather than to mess up the book. This is the manual that I got. It covers models 308, 309, 310, and 312. And it comes from Glendale Manuals. Here is some information I got from one of my viewers that gave me a link to it, and I did a screenshot of it and blew it up so I can read it. It just basically tells about the Radio City Model 308 tube tester. And it gives some information in here that I didn't know, so I just added that. This is the instruction, but it's very, very fine print. So what I did is I had my wife scan this in as a PDF. I can't scan with my scanner because I got too much junk on top of my flatbed scanner, my printer scanner combination. So I had her do that, and then I could read this off the computer and blow it up as big as I need it. And here are the tube setup charts. And some of my viewers have told me that the A is not the socket, but it's the switch for the tube function. That makes sense. Yeah, here's what I've been reading wrong. Tube select. Tube select. I read that quick and I thought that was the tube socket. So, as always, with bad eyesight, I have a habit of reading wrong too. So anyways, this is the setup charts, which are nice and easy to read. And here's the original schematic. And here is the same schematic that I blew up, because I got the online manual also, and blew it up and printed it out on this so I can work from this, so I don't have to get the book dirty. Now I'm gonna get the magnifier over here. 14.5. Now I wrote that in because it wasn't marked, but it is marked on the original schematic. If you look really carefully there, I'm getting a lot of reflection here, so I don't know if you can see that, but if you look at the meter, just below the meter is a resistor. I'm moving this around, so hopefully you'll be able to get it in and see it. I'm still looking on eBay for a camera that will do macro, that will take WVGA, and a little pocket type like I've got here, but preferably a fixed focus so it doesn't keep going in and out of focus. There's nothing more irritating than, you know, having a camera going in and out of focus. You know, so I'd like to be able to get one that has a switch on it that will, you can switch to macro. If anybody has got any ideas where I could get one, I don't want a donation. I want to be able to get somebody to give me a model or something that I could look on eBay and maybe find something that's within $30, $40 price range, probably at the most. Because what I'm trying to do is to get down, this won't get down very close, roughly about 8 to 10 inches, and that's about it. But there is a resistor right there that says 14.5, which is on the original schematic. I'll get it over here, maybe you can see it better. It doesn't, I don't know if that's 14.5 ohms, 14.5, 14,500. We'll find out very easily by taking some measurements. And if you look down at the bottom, the very bottom of the schematic, where it says 105 to 130 volts, 60 cycles, there's the primary of the transformer, and there's the rheostat, and 18,000 ohms is the resistor right there, and that should be this one right here. Now there is a discrepancy on this, because this one I got off online, and this one came in the mail. Look down at the bottom here, where the 18,000 ohm resistor to the right, there is a resistor, what looks like it's in series with part of the primary. Okay, take a good look at that and picture that in your mind. Okay, now keep that in your mind, and I'll pause this camera right now. Okay, this is the original schematic book I got. It shows the rheostat there. 18,000 ohms to the right, it shows that rheostat. See the slider on it? Now we'll look at the other schematic. It's not showing the slider. Is this a misprint or what? Now, I can stick a meter on this and measure this, but I think what I'm going to do is I'm going to measure this and find out what that 14.5 is. Now, to be safe, I'm going to shunt out this meter with a clip lead, because I don't know what the microamp range is on this meter. It could be extremely sensitive. I don't want to blow the meter with the ohm meter. Chances are I wouldn't. So I'm going to shunt this out, and then I'm going to take and put an ohm meter across here and see. That sure looks like a capacitor. It sure does, but it's, according to that, the schematic, it's not. Now, if it was a capacitor, it's in series with the meter really wouldn't work. The meter's a DC movement, deoscible movement. So if you put a capacitor in series, you're not going to get any deflection unless the capacitor is shorted. So that probably is a resistor. So the only one way you'd find out, and we'll put the meter on it. Hang on a minute. All right, that seems to read 18,000 right there. I did check it quickly in a red high, which is probably the reason why I'm not getting anything higher than center scale on the line set. The line set should go over that, and in other words, you should have the ability to go higher by a small degree, and then when the tube is in, you can adjust it. Otherwise, if you can only get it to the center, which is what's happening now, and when you put a tube in, it's going to be loaded down, and you need to adjust it and bring it back to center again with the tube in. This resistor has to be changed. This here is apparently open. This control is a 600 ohm. You cannot see it from here, but if you look in here, it's upside down. That's 600 ohms. And on the original schematic, very, very, very faintly, you can see it. With this magnification, you can see it. Look at the primary of the transformer. Look at the rheostat just below that. And just above the rheostat says 600. So that is correct. That's 600 ohm control. Right now I'm reading about 14 ohms. I'm reading 14 ohms, and the reason is I'm running through the primary of the transformer, so that's not the way to test it. So I can't do anything until I replace this. I'm going to check this now and see what it is. This resistor here. Okay, I got my meters clipped on it here. Let's see what we're reading. We're on the 200,000 scale. This is not auto scaling. Here's 20,000, so it's over limit. So we're on a 200,000 ohm scale. You're reading the bottom right here, right there. And we're at 94.8 thousand ohms. So I got to replace that resistor and remove this, because this was in parallel with this. So this is probably the original, and this was added years ago. So they both got to go, and I think what happens is when these go, it's too small of a wattage. I would probably say at least a 10 watt should fit right in there nicely. 10 watt wire wound would be good. I don't have one. I have to order all my stuff, and ordering from eBay, I can only order one value at a time because that's the way they sell them. So I'll probably end up with my local electronics shop, which charged me about $2.50 for one resistor. But that's the way it is. But you only need the one. So, okay, so we know we got to replace this, and I'm not doing anything because I don't have an 18,000 ohm resistor of a 10 watter. I would have a low wattage, half watt, quarter watt. Obviously, I'm not going to use that. Got the meter shunted out. And like I say, I don't want no damage to the meter because I'm going to be reading this resistor here. Now, if you'll notice, and put you to the magnifying here, you see one meter lead here? It's going underneath that. See it? So this is in series. So we're going to measure this. So I'm going to get the leads on it, and we'll check, bring you up to the meter, and I want to see what that is. That's supposed to be 14.5, but I don't know if it's 14.5 thousand or what it is. We'll find out. I got my meter leads on that resistor. Let's take you up to the meter here. All right, here's the 20,000 ohm. All right, let's see what that is. 14.5, so that would be on the 200 ohm full scale, 16.4 ohms. So that would explain why the meter is reading a little low. It's supposed to be 14.5 ohms. So like I say, it was marked in the schematic here as 14. I don't know if you can see that. See the 14.5 right there? So I wasn't sure if that was 14.5 thousand. Obviously it's 14.5 ohms. So we're reading 16, so we're reading 2 ohms high. So that would explain why this tube tester was reading a little low compared to this guy's TV7. So what I'm going to do is to change this out with a 14.5 ohm precision resistor, and because it's in the meter circuit, I could use a quarter watt or a half watt. I might have it. If not, I could probably make it up and get the values to 14.5 ohms. So obviously this is reading a little too high. I never worked on very many of the real old radios. I've done a couple of them in my time, so I'm not familiar with this, and this always looked like the old mica mold capacitors. But obviously it's a resistor because logic says you can't use a capacitor to run a deoscillable meter movement unless it's going to be reading AC, and in which case it would pass AC. Capacitor don't pass DC, so this is a resistor 14.5 ohms. So it's not supposed to be 16.5. All right, I'm going to look up on the schematic on this because I was never good at dog bone resistor color codes. Body, dot, end, I'm not sure how that works now. I'm not that experienced with that. I'm sure some of you guys will chime in. Brown body, orange dot, black end. Or do you read it this way? Black, It's orange or yellow. Looks like orange to me. Black, orange, and brown, or brown, orange, and black. Well, thank goodness I got the schematic anyways. So with the schematic, I'll trace it out. And there isn't that much in here. There are some resistors here. But like I say, I'm not going to shotgun this. This here, this looks like a new wire. This white one. Because they use cloth-covered wires all in through here. Or rubber-coated. This is the spare socket right here, which you're looking at. I'll turn this around a little bit so you can see that. This here is the spare socket for obsolescence. So you can add another. Has a little bit of that fuzzy little whiskers on here that I was brushing off on the last video with the dry paintbrush. I had a lot of that all over. Obviously I missed a spot here. But it's in very good shape. And this thing came quick in the mail, very quick. It was supposed to be here the 10th, and it came in very quick. Now you see this white corrosion here on these studs from the switch. I think take a little bit of oil on my fingers and just go around that very carefully, not to get it on the contacts. And that should help that. But overall, it's in good shape. But as you can see over here, there are, well, here's another one of them. There could be resistors. This is a resistor, but these two look like this. So these could be resistors here, and here is a, in case you guys don't know what these are, hang on a minute. This is a flexible resistor right here. Low wattage. I've seen a few of these in my time. These will all have to be checked out, and the way this is made, it's just sitting up here like this. So, I mean, that's just the way they made it. That's just the way they made it, you know. It's just like this supports everything here, so it's heavy, stiff wire. So if any of these have to be replaced, if they're open, I can use it as a support and just put a resistor from here to here. If they're not open, but off value, usually going up in value, I may have to remove them or shunt them out, but I don't like to do that because then if this goes up even further, the values will be off, and I think I'm getting my fingers in the almost in the lens here. I have a habit of doing that sometimes. So anyways, I cleaned up the NE51 as best I could without removing it. Now the schematic shows 500,000 ohms. Again, I can't read dog bone resistors. Here's a close look. It's sitting across the neon bulb. And here it says 500,000 ohms, so 470,000. So if that's out of whack, I could always put in a 470,000, because that's a standard value. Let's see. Yellow, violet, purple? I used to know some of these codes by heart. Yellow, purple, yellow. 470,000 ohms. But I don't know about the dog bone. That looks like a yellow dot. But I don't see any purple there. So they don't use a standard resistor color code apparently on the dog bones. I think what they did is they all had different color codes. So thank goodness for the schematic. Whatever the schematic calls for 500,000 ohms. So if this is off, I could test this easy enough. But when I'm ready to change out these things that are off value, I will do that. So anyways, I think that's going to conclude this video. But I want to kind of get an input from you guys out there as to what you think I should do. Is it okay to put modern stuff in this? You gotta change the resistors. I mean, if they're bad, you gotta take them out and put modern ones in. But on something that's this old, and you want to keep its value, I guess, but I don't know. It's not a museum piece, obviously. The question is it the right thing to do? Or do you just leave it alone and don't want to stick it on the shelf? I want it to be working, and I want it to be a working tube tester, and that's what I bought it for. So just want a little input from you guys there, and mainly on the dog bone resistors. They seem to be a different color coding than they use on the resistors I'm used to using, and thank goodness for the schematic, because whatever the schematic calls for, that's what will be replaced. And I do know that these resistors, like the dog bones and stuff here, like you see right here, are bigger for their wattage. So this is probably only a half a watt right here. It's only about 3/4 of an inch long. So that's probably only a half a watt, because they were large back then for the wattage ratings they were. Okay, that's it for today. I can't do anything until I get some parts for this. What I'll do off camera, though, is I'll measure these resistors and establish which ones I need. And that way, when I go into it, I'll be able to do that. Because I do have to replace whatever is open or gone way up in value or whatever. And the cabinet, as you can see, might as well say there's basically very little of this stuff on here. So something would have to be done to it in the future. Now this is the cover, and this is what I saw in the auction here also. And the cover is typical. It's a mess, but that's what you expect. It's been repaired. Somebody had put little brads in here to hold it together, I guess. Although it seems to be held together pretty good. But it could be painted, I guess, or it could be left the way it is. All right, so that's it on this one. When I get to get the parts and everything, there'll be a video on it, so don't go away. Thanks for watching. You have a good day, and stay out of the snow.